Lesson 8.3 is the graphs of sinusoidal functions. So here we have a Ferris wheel going around where it starts off at its lowest point and then goes to the maximum, comes down back to the lowest point and repeats itself. So how high off the ground is the Ferris wheel? And if you look, it's the y coordinate of the lowest point. So if you look, that in this case, we're looking at the y coordinate, which would be 2 meters off the ground. Determine the maximum value of the graph. This is the maximum height that will be reached. Again, we're looking at the y coordinate of the point which is highest, and that is 160 meters. Determine the minimum of the graph, and that's equal to how high the Ferris wheel is off the ground. So that's also 2 meters as A, same as A. What is the height of the Ferris wheel? So the height of the Ferris wheel can be found by taking your max and subtracting your minimum value. So we know that the max was 160 and our minimum was 2. So our actual height is 158 meters high. So that's the diameter of the Ferris wheel. Our domain is always looking at the x value. So if you look, our graph starts at time 0. So we would say t for times, where t is greater than or equal to 0, but less than and equal to 60. And we would say TER. So the graph does continue after that, but this is all that we can see. So we'll just use that. And determine the range. The range is from the lowest to highest point. So this is using our minimum and maximum. So h for height, where h is greater than or equal to 2, but less than and equal to 160 meters YER. And in this case, I'll use HER for consistency. Determine the amplitude of the graph. The amplitude of the graph can be found by taking your max minus your min and dividing it by 2. So our max is 160, subtract our minimum of 2, and we're dividing that answer by 2, and we'll get 158 divided by 2, which is 79 meters. So this actually represents the radius of the Ferris wheel. And then we have our midline. Our midline is found by taking our max, added with our min, and then dividing by 2. So we'll have 160 plus 2 divided by 2, which will be 162 divided by 2, which is 81 meters high. So this is the halfway point between the highest and lowest height. This is another name of saying your average height. So this is your average height that is reached by this Ferris wheel. Determine the period of the graph. So explain your method. So I'll go back and I'll show you what I'm doing. So I'm starting at the minimum, and we want to find out when it returns back to the minimum. So when it returns back to the minimum, the time that takes is your period. So how long does it take for you, once you get on the Ferris wheel, to return back to your starting position? In this case, it's going to take 30 minutes. So we're always looking at the x value for our period. So 30 minutes. So explain our method. The x distance between our minimums. Now that is the same as the time that it takes to make one full revolution. So our period is the same as the time it takes to make one revolution around the circle. And now how long does it take to get from the top of the Ferris wheel to the bottom? So this is half the period. So anytime you want to go from a max to a min, or the min to the max, the distance that it will take along the x value will be half the period. So 30 divided by 2 is 15. So it's going to take 15, and we're in minutes. So 15 minutes to get from the lowest point to the max to the highest, or from the highest to the lowest. So the midline is going to be the values. So the midline is going to be represented by letters A, C, and E here. The reason being, so that's the halfway distance between your maximum height and your minimum height. Your amplitude can be found by taking your value of your max and subtracting your midline. So that's one way to get it. Or you can take your midline and subtract your minimum value. So those are some options. You could always take your max minus your minimum value and divide that by 2. So there's lots of different methods to find out your amplitude. Your period would be from A to C here, or A to E, sorry, A to E. So a way of calculating that is if you took your x coordinates from E and subtracted the x coordinates from A. So that's just showing you how to actually calculate it. You subtract between the two. Your maximum is at B. Your minimum is at D. Your x-intercept occurs at letter D, and your y-intercept occurs at letter A. So those are just a few ways to calculate those values. So it just depends on what you're given in the question. Example number 1, they want you to graph, the graph of a sinusoidal is shown. Describe the graph by determining its range, median, equation of the midline, amplitude, and period. So the range is going to be from y such that y is greater than or equal to, the lowest value that you can see is -3, up to the highest value is 7, and then we would say YER. The median is the same as the midline, and that's taking your max plus min divided by 2. So 7 plus -3 divided by 2 equals 2 if you calculate it. The equation of the midline is just writing it as y equals 2. So this answer just goes there. The amplitude is max minus min divided by 2. So that'll be 7 take away -3 divided by 2 equals 5. Our period is, since we're starting at the lowest value, when does it return to its lowest value again? And you can see that that is going to count for 3 blocks. 3 blocks. Well, we need to find out what 1 block is. Well, 2 blocks is 120, which means that 1 block is 60 degrees. So if we take 3 blocks times 60 degrees, we're going to get that the distance is 180. So we know that the period is 180 degrees. Example number 2, same questions. They want the range. So we're starting from -4 and going up to +2. So this is our lowest height up to our highest height. The equation of the midline is that halfway point. So sometimes you'll be able to see it, but if not, remember you can use the max plus min divided by 2. So that'll be 2 plus -4, divide that answer by 2. And the midline is actually equal to -1, but we need to write it as an equation. So we have to write y equals -1. The amplitude is the distance from the midline to your maximum, or the distance from the midline to your minimum. So max minus min divided by 2. So that's going to equal 3. Our period, as you can see, sometimes it might not be clear on where our period is. So you can find, if you find the distance between your maximum and your minimum along the x-axis, so I'm going to calculate that, and if I double that, that's actually going to equal your period. So this is going to be, your period is going to be equal to this times 2. This distance multiplied by 2. So I know that I have 3.75 minus 1.25 along the x's. And so what we're going to do is find that answer and multiply it by 2. So that's going to be equal to 2.5 multiplied by 2 gives us a 5. So our distance of our period along the x-axis is 5. Example number 3 is we need to use this data to sketch what our picture, our graph is going to look like. So things that are given that we're going to use are that the y-intercept is 2. So I'm going to plot 2 on the y-intercept, and that's done. And then I know that pi is equal to 3.14. So at 3.14, I'm going to repeat that y-intercept value of 2. So that shows that there's a repetition involved. So at 3.14, I have 2. And then at 6.28, which is 2 pi, so that's doubling that period, I'm going to have another value of 2. And it does say to go from the domain of negative pi all the way to 2 pi. So my graph will stop right here. So I'm not going to have anything past this 2 pi value. So this is 2 pi here. This is my pi value right here. And then at negative 3.14, I'm going to have the value of 2 again. So that's again where I need to stop the graph, because my graph should only go from negative pi to 2 pi. It also tells me that my graph needs to go from negative 5. So I'm going to cut it off here. So I can't have anything. I can have the graph touching negative 5, but nothing below this dotted line. And up to 9. So again, we want the maximum to go up to this dotted line. Okay, so then all we're doing is graphing a picture between those values. So I'll use red here. So what I am doing is I am going from that point, I'm going downwards. Now you can choose to go upwards from that first point. Then you're going to go through that point and up to the maximum, down to that y-intercept, to the minimum, and then to that y-intercept value that we had, which was 2. So this would be a picture that would represent this. Now, another picture that you could have drawn is you could have gone up to the maximum first and then down to the minimum, up to the maximum, and down to the minimum. So these are some options. Example number 4. So we have 2 swings that we're comparing. It says that they have graphed an example of simple harmonic motion. So Morgan swung on a swing and Lily used a motion detector to measure Morgan's height above the ground over time as she swung back and forth. The girls have graphed their data as shown. At the end of each cycle, the swing returned to its initial position, which resulted in a sinusoidal graph. Interpret the graphs of swing 1 and swing 2 within the context of the graph. So our domain for both of them is going to go from 0 to 6. So I'm going to put 1 and 2, meaning that it refers to both swing 1, swing 2. So we'll use time in this case. T for time. T is greater than 6 and equal to 6, but less than 6. So greater than 0, but less than 6, TER. Range. The range, if you look at it, will be slightly different for both graphs. So for swing number 1, the domain will go from 0.75. We can say H for height. Up to, our maximum height is 2 for swing 1. Now swing number 2, our minimum is 0.75, so they're the same distance above the ground. But it goes higher, so that means that this swing was pushed farther up to a height of 2.5 meters off the ground. Now there's no x-intercepts for both graphs, and the y-intercept for graph number 1 would be 2 versus the y-intercept is 2.5. So what that means is that the graph started at its highest height. So when time was 0, what they're doing is they're pulling the swing back and letting go. So the first swing was started at 2 meters off the ground versus swing 2 was started and pulled back to 2.5 meters off the ground and then was released. And then it swung back and forth between them. So how long it's going to take to return to its initial starting point, meaning all the way up, would be at a distance for the first one of 1.5. So swing 1, the period, is equal to 1.5 seconds versus swing 2, the period is actually, if you look at the max, when it returns to the max, it's 2 seconds. Now it's going to take longer because it went a greater distance. And then we have our midline. So our midline is going to be the halfway point. So you can actually count your blocks. If you count, there's 1, 2, 3, 4, 5, 6, 7 blocks for swing 2. So in this one, I'm going to actually calculate it. Your max minus your min divided by 2 for your midline, or max plus min divided by 2. Max plus min. And that'll be the same for the first one. It'll be then 2 though, because it does have different values. Max plus min divided by 2. So for the first one, when you're doing your median, you should get 1.375. So this is your average height above the ground. And then the other one was 1.625. So this one has a higher average of height above the ground in meters. Then we have our amplitude, which represents the radius of this situation, if we're talking about the circle. So remember, your Your amplitude is found by taking your max minus min divided by 2. So for the first graph, you should get that 0.625. So that's just taking 2, subtract 0.75, dividing by 2. And then for graph number 2, or swing number 2, you should find that the amplitude is 0.875. So when comparing the swings, we know that swing number 2 has a greater radius, it has a higher midline, it has a longer period, and the y-intercept, the starting point above the ground, is higher for swing number 2 as well. So that would be just comparing them in the context of the question. So we know that the radius of the swing for swing number 1 was 0.625 versus 0.875. And then our average height above the ground for graph number 1, we said that it was 1.375 meters versus for swing number 2, it was 1.625 meters off the ground. And then we can compare the periods. We can say that it took 1.5 seconds for it to return back to its starting position for graph 1 or swing 1, and then swing 2, it took 2 seconds to return. So those are all the things that we can mention for this question. Now we want to find out what was the height above the ground for swing 1 and swing 2 for 4 seconds. So we're going to use our graphs and we're going to look at 4 seconds. So you're going to mark off where 4 seconds are and approximate what the swing 1 was. So the height above the ground for swing 1 would have been about 1 meter. And for swing 2, it's the highest height, which was 2.5 meters. So that's just using the graph. So this is the height at 4 seconds for both of the swings. Okay, so here again, we're comparing the two kind of items. So we have, let's start with domain. So the domain is the same for both. We're going to approximately, I would say, we're going to 3. And so I'm just going to draw an arrow to show that that would be the exact same amount. And then our radius, or our range will be different. So for our range, we would use h for height. We're going from 0 up to 24 YER. So, or HER. So the reason it is touching the ground is because this is a wheel, so it's going to graze the ground. So it's going to go from 0 to 24. So this is the distance from the bottom of the tire to the top of the tire. So this is the actual diameter of your tire that we're looking at here. Versus this one, it's going to go from 0 up to 32. So we know that the pickup truck has a bigger tire, just from this information here. And then we have our y-intercept. So this is when the tire is going on the floor. So these are the times when there's, because they put a little chalk mark on this tire. And so whenever that chalk mark on the tire hits the ground, that is where it is an x-intercept. So we know that there's one at 0.6, another one at 1.8, and 3. So this one, the x-intercept will occur at 0.8, sorry. So it should be 0.8, comma, 2.4. So those are the 2 times that it hits the ground. The y-intercept is 24. So the chalk mark is actually at the very top of the tire when we start rotating it. So we're at 24 inches versus the y-intercept is also at the top at 32 inches. The median can be found by taking your max plus min divided by 2. So this is your average height above the ground. So that halfway point, the halfway height between the max and the min is going to be 12 inches for the car, and it's going to be 16 inches for the pickup truck. The amplitude is the radius of your tire. So from the inside, so the inner corner, so the inside piece, the central point of your tire to the very edge, it's going to be 12 inches. So this is a 12-inch tire versus this is a 16-inch tire if you take your max minus min divided by 2. The period. Now a smaller tire will always have a smaller period. So it's going to be 1.2 seconds. If you look, for it to reach back to the maximum, it takes 1.2 seconds. And the period for the bigger tires, it's going to take, to get back to its maximum, it's going to take 1.6 seconds. Okay, so a bigger tire will always take longer to rotate and etc. It's going to have a larger average height and it's going to have a larger radius as well in this case. Okay, so that's